A quarterback releases a pass at a height of 7 feet above the playing field, and the receiver catches the football at a height of 4 feet, 30 yards directly downfield. The pass is released at an angle of 35 degrees with the horizontal, and we want to write a set of parametric equations for the path of the football. So first of all, we know that x is going to be equal to our initial velocity times the cosine of 35 degrees times t. And our y is going to be the initial velocity times the sine of 35 degrees times t, plus the height that the ball is released is 7, so h will be 7 minus 16t squared. So for part A, there are our two parametric equations. All right, part B, we want to find the speed of the football when it's released. So going back and looking at the information given, we're told that the receiver catches the ball when it's 30 yards directly downfield, so that would be our x value. But we have to be careful because this problem is in feet, and if you have 30 yards would be 30 times 3 or 90 feet. So 90 is equal to v sub 0 times the cosine of 35 degrees times t. And we can either solve for v sub 0 or solve for t, or I'm actually going to solve for both. V sub 0 times t will be equal to 90 divided by the cosine of 35 degrees. So now we're going to take this value and substitute it in for v sub 0 times t in the other equation. Now what we know about this equation is that when the receiver catches the ball, he's at a height of 4 feet. So y would be 4 feet, and that's going to equal the sine of 35 degrees times v sub 0 times t, which would be 90 divided by the cosine of 35, plus 7 minus 16t squared. So now we just want to solve this equation, and we're going to solve it for t, and then once we know the time, we'll be able to go backwards and find the initial velocity. So to simplify this down a little bit, we can subtract 4 from both sides. And that will give us 0 equals. We can also note that we have a sine divided by a cosine, and sine divided by a cosine is a trig identity. That's equal to the tangent of 35 degrees. Now you don't have to work it this way, but it will compact it a little bit. And then we subtracted 4, so we're going to have plus 3 minus 16t squared. So 16t squared is equal to the tangent of 35 degrees times 90 plus 3. So t squared would be equal to that amount we have divided by 16. And so t will turn out to be the square root of the tangent of 35 degrees times 90 plus 3 quantity divided by 16. And so if we enter that on our calculator, we get that t is approximately 2.0313 seconds. So now we need to go back and answer our question, which was, what was v sub 0? So going back to what we wrote a moment ago, v sub 0 is equal, times t is equal to 90 over the cosine of 35. So we now know what t is. So 90 divided by the cosine of 35 equals v sub 0 times t, which is approximately 2.0313 seconds. So our v sub 0 is going to be 90 divided by the cosine of 35 divided by 2.0313 seconds, which is v sub 0 is approximately 54.088. And this would be in feet per second. So for the next part of the question, we're going to need to get out a calculator and enter our two equations, which we now have x is equal to 54.088 times the cosine of 35 degrees times t, and y is equal to 54.088 times the sine of 35 degrees times t plus 7 minus 16t squared. So if you'll enter these two equations on your calculator and then trace over to find the maximum value, you should be able to find that your maximum value is approximately 22 feet. So that would be the maximum height of the ball. And then for part D, it says find the time the receiver has to position himself after the quarterback releases the football. Well, that's the time that we already found. So the answer to part D would be 2.0313 seconds.